Hi, if you wonder how analysts make graphs with shaded area, these two videos are for you. I'll walk you through the Bollinger Band example with detailed code explanation. Then in the next video, we'll apply the graphing technique on our Bollinger Band example. Let's dive in.
Here I specify the CSV file location. Feel free to refer to this video for stock data download. This is a data file that contains 3,000 plus rows. It's a simple data being uploaded to my GitHub. From this website, you'll see a CSV file. For the CSV, just treat it as data separated by commas. It's just one way of arranging data. In case you don't know how to install Jupyter Lab, simply click the video on the top right. It will show you right from the very beginning on how to set up Python and Jupyter Lab. Shift Enter to run this cell. Then I need to import some libraries. You can treat libraries as a group of coding commands. Here we need to read CSV and toDateTime from pandas. Just pretend that these are the two coding commands. We also need NumPy for quick calculations and Matplotlib for graphing. From Matplotlib, we need pyplot. Since we don't want to type matplotlib.pyplot every time, we just use the short form plt. Shift Enter to run the cell, and you see a star indicating loading. It takes a while to load 3 libraries. Oops, done. Here I create a variable df data frame to store the stock data. df equals read CSV, then a bracket wraps around. Here we can shift tab to view the parameters. The first one, file path, simply refers to the file location. The file can be a CSV file stored locally in your disk or an upload file ready for download. In this case, we don't need to specify the parameters below as the stock file is pretty well formatted. You can simply type file and shift enter. Usually, I'll df.tail to preview. Inside the bracket, by default, is 5. You can view the last 10 or 13 rows. Leave it blank and you're viewing the last rows. Shift Enter and you're now viewing the last 5 rows. On the leftmost column, you'll see the index in sequence. The main purpose of index is identify data location with respect to the unique row index. In this case, we only calculate the Bollinger Bands, so I can wipe out the numerical sequence. But remember, each data frame has to have at least one index. That means at least one column that contains unique reference. Instead of a numerical sequence, here we use the dates as reference because each day is unique. Before proceed, you can see the date is lengthy as it contains the hours, minutes, and seconds. So go to the table, df square bracket single quote followed by the column name, date. Let's preview the last 5 days. It will be like this, and let me chop off the dates end. For the date column, toDateTime, here we use toDateTime to convert the dates into datetime object. Go back to the date column, comma, and specify the format as equal quote a % key. Y refers to a 4-digit year like 2022, 2023, 2002, something like that, dash %m, which stands for month like 1 to 12. And then the date D, 1 to 31st. Okay, shift enter and go back. df.tail to preview. Shift enter and you'll see that the date only contains year, month, and day. Now we want the date column to be the index. Simply df.setIndex and then bracket. Insert the column name inside a single quotes, which is the date column. Shift enter. It prints out everything. So I df.tail and I need in place equals true. Now the stock data table has the date as the index. Let me start the Bollinger Band calculation. On a close price, we get the 20-day moving average. df. Here I create a new column, SMA, simple moving average. You can name it whatever you want. The SMA column will be here. For the close price column, we'll take an average by rolling 20 days backward. And .min to get the average. Shift-Enter, oops, should be window. Just be aware of typo. As you see, anyone can forget the parameters. So usually our Shift-Tab and window is at the first place instead of Windows. You can Google the rest of the parameters by yourself. I won't repeat here. Shift-Enter and df.tail to view the last 5. And as you see, the 20-day moving average column. If I df.head to view the first 21 rows, Shift-Enter and you see NAs not available in the SMA column. The NA appears until the 21st row because we can't calculate the 20-day moving average for the first 19 days. Usually, I'll get rid of the NA, not the NA, okay? df equals df.drop NA, Shift-Enter. Let me df.head to view the first 5 days. Shift-Enter, and you should see the figures start from November 12, 2009. Just show it here. Now we have the center line of the Bollinger Band 20-day average. It also has upper and lower band, just like the Bollinger Band at the very beginning. Right in the middle is the 20-day moving average. On top, it is the upper band and the lower band below it. To get the bands, we add 2 STD, standard deviations, to the center line. So what is standard deviation? The first standard deviation is the first zone of data around the average. The next zone is the second STD, and so on. Let me store the standard deviation in a variable, STD. The standard deviation is calculated on the close price. It's equal to the moving average rolling for the last 20 days. Simply .std to return the standard deviation. Alright, just do it in a new column for demonstration. View the last 5 rows and you see the standard deviation. With the moving average and the standard deviation, we can calculate the upper and lower band. Create the column UB, which stands for upper band, is equal to the sum of the SMA, the 20-day moving average, and 2 times the STD, standard deviation. After the upper band, here we have the lower band, which is minus 2 STD from the SMA. To sum up, the upper band is 2 STD above the 20-day moving average, where the lower band is 2 STD below the moving average. The Bollinger Band is simply a textbook definition. Whether you want to change to include different STD is totally up to you. But in general, the Bollinger Band refers to 2 STD. Shift-Enter, df.tail, let me view the last 5 days. From Jan 25th, 2022, the SMA is about 23,800, STD is about 650, so the upper band is the sum of 23,800, 2 times the STD 650, which is about 1,300. 23,800 plus 1,300 is about 25,100. That's this 25,100. Similarly, the lower band is 23,800 minus 2 times 650, which is minus 1,300. 238 minus 1,300 is about 22,500. The same calculation is done for all the 3,000 rows in a data.